So we'll start new module 4. So coming to introduction and digital instruments in the first class. So we have the voltmeters which use, coming to electronic instruments, measurement of electronic using measurement using electronic instruments. The voltmeters which use rectifiers, diodes, amplifiers, and other supporting electronic circuits to produce a current proportional to the quantity to be measured are called electronic voltmeters. In olden days, vacuum tubes were in use, and the voltmeters were called vacuum tube voltmeters. But nowadays, transistors and semiconductor diodes are used in the electronic voltmeters. A voltmeter in which transistor is used is called transistor voltmeter. The field effect transistors are also used at the input side, and such voltmeters are called FETVM. So there are certain advantages of electronic voltmeters. See, coming to the advantages of electronic measurement, most of the quantities can be converted by transducers into electrical or electronic signals. An electrical or electronic signal can also be amplified, filtered, multiplexed, sampled, and measured. The measurement can easily obtained in or converted into digital form for automatic analysis and recording. The measured signals can be transmitted over long distances. Many measurements can be carried either simultaneously or in rapid succession. Electronic circuits can detect and amplify very weak signals. Electronic measurement makes possible to build analog and digital signals, and it has higher sensitivity. So let us come to to discuss in detail about electronic voltmeters. What are the different considerations in electronic voltmeter? The selection of the appropriate type of voltmeter which can give the accurate reading depends on the number of factors. It mainly depends on the performance of the instrument required in a particular situation. The various considerations in selecting the proper instrument are input impedance, voltage range, decibels, sensitivity versus bandwidth, battery operation, AC current measurement. So let us discuss one by one. What is input impedance? The input impedance of a voltmeter should be as high as possible to avoid the loading effect. At least it should be higher than the impedance of the circuit under measurement. So next one is voltage ranges. The voltage ranges available on the meter scale may be in a sequence of 1, 3, 10 with 10 decibel separation, or in a sequence 1.5, 5, 15, or in a single scale calibrated in decibels. The voltage ranges and the accuracy must be compatible with each other. Next, coming to next consideration in electronic voltmeter is decibel. The unit decibel is used to achieve wide range of the quantity as it uses a logarithmic base. The decibel unit can cover wide range of voltages effectively. The decibel is expressed as dB, but all the voltmeters are calibrated in dBm, that is reference to some particular impedance. Next consideration is sensitivity versus bandwidth. The noise is a function of bandwidth. Lesser the bandwidth, less is the pickup of noise, while the voltmeter with broad bandwidth is sensitive to pick up more noise. In general, the voltmeter with a bandwidth of 10 Hz to 10 megahertz has a sensitivity of 1 millivolt. Some voltmeters having a bandwidth up to 5 megahertz could have sensitivity of 100 microvolts. Next consideration in electronic voltmeter is battery operation. In case of field work, the instrument provided with the internal battery is very much essential. Next, coming to the AC measurement. Next consideration is AC measurement. The current measurements can be made by a sensitive AC voltmeter and a series resistance. The current probe can be used effectively as it does not disturb the circuit under measurement. This is because the current probe directly measures the current through the circuit. So next, what are the advantages of electronic voltmeter? So we have so many advantages. To list few, first one is high input impedance to isolate meter from the measurement circuit. Secondly, the amount of power drawn is very low from circuit under measurement, so no loading effect. Thirdly, the sensitivity is very high, as much as 100 times the normal PMMC voltmeter. So next is the gain of the DC amplifier allows the voltmeter to be used for the measurement of voltages in the millivolt range. Finally, the overload cannot damage the meter because amplifier saturates and limits the current through the meter. These are the few advantages of electronic voltmeter. So we can see here voltmeters and discuss in detail about voltmeters and multimeters. A basic DC meter uses a motoring principle for its operation. It tunes that any current coil placed in a magnetic field experiences mechanical force. So DC instrument, using shunt resistance, DC current can be measured. Using series resistance called multiplier, DC voltage can be measured. Using a battery and resistive network, resistance can be measured. So the instrument is ohmmeter. So coming to AC instrument, using a rectifier, AC voltages can be measured at power and audio frequencies. Secondly, using a thermocouple type meter, radio frequency voltage or current can be measured. Using a thermistor in a resistive bridge network, expanded scale for power line voltages can be obtained. So this is the basic voltmeter. You're looking at the diagram. You can see the multiplier which is connected in series with the basic meter. The basic DC voltmeter is nothing but a permanent magnet moving coil, d-Orson galvanometer. The resistance is required to be connected in series with the basic meter to use it as a voltmeter. So this resistance is called what? Multiplier. So coming to this voltmeter, this is how we can calculate using the relations, how RS can be calculated, how multiplying factor M can be calculated. The voltmeter must be connected across the 2 points or a component to measure the potential difference with the proper polarity. This is very, very important. So that completes the discussion about voltmeter, basic voltmeter, introduction about the